So we talked about finding derivatives of power functions, derivatives of products, derivatives of quotients, derivatives of trig functions. Now let's talk about the derivative of a composition. So this is known as the chain rule. And when we're looking at this, here's a composition where I've got 3x plus 2 is inside of the squared function. I can easily find this out. I can multiply this out, just no problem whatsoever. I can multiply it out and then find the derivative. There's no issue there. With this one to the 25th, this again is 3x plus 2 into the 25th power function. Again, I could do it. I wouldn't want to, but I can multiply this out by itself 25 times and find out what that is. But I really don't want to. This one here is the square root of 3x plus 2. So again, it's 3x plus 2 inside the square root function. So it's a composition, and I cannot multiply this out to find out what the derivative is. So I need to have some rule that lets me do composition functions. And again, that's known as a chain rule. And what the chain rule says is if f and g are both differentiable functions, and f is a composition of f and little g, or f of g of x, whichever way you want to think of it, then big F is a differentiable with big F dx is equal to the derivative of little f evaluated at g of x times the derivative of g of x. The way I like to think of it is this is the derivative of the outside, evaluated at the inside, times the derivative of the inside. You can also do it as dy dx is derivative of y with respect to u times du dx. That's another way to think of the chain rule. So let's do a couple of examples. Let's find this derivative. First thing I'm going to do before I do this, just having a little trouble with my technology is not working. There we go. Okay, so the first thing I'm going to do is I'm going to rewrite this. I don't like square roots. I like power functions. So I'm going to go rewrite this in terms of a power function. Then I'm going to go find the derivative. So the first thing I need to think about is what is my outside function? And what's my inside function? So my outside function, and that's a little long to write. So I usually write this as O period F period for outside function. And my outside function is something to the 1/2 power. So it's something to the 1/2. And if you don't want to put the X in there, you don't have to. You could have just left it blank. It's something parentheses to the 1/2. The inside function, again, that's a little long to write. So I might write that as IF. That's the thing that's inside the parentheses. So it's the 3x plus 2. Now, if I go to do this derivative, it's the derivative of the outside function times the derivative of the inside function. So my outside function is 1/2 something, and I won't fill in the parentheses this time, but something to the negative 1/2 power. Remember, bring the power down, subtract 1 from the power. So there's the derivative of my outside function. The derivative of my inside function is the derivative of 3x plus 2, which is just 3. And then what I put in as something is the 3x plus 2. Whatever was inside goes in there again. And there's my derivative. Let's try another one. Again, I might think about this as y is equal to something squared, and it's cosine x is being squared. So that's what cosine squared x means, is it just means cosine x is being squared. Again, I'm going to go find my outside function. That is something being squared. My inside function is the cosine of x. So now my derivative is the derivative of the outside, which is 2 times something to the first, then times the derivative of my inside, which is the negative sine x. And then all I got to do is put in what was inside. And that's the chain rule.